Well, we're back on to CBs. We've got no customer repairs in, so it's one of our stock sets. It's obviously come in a box of junk. It does come with the factory original microphone, and it comes along with a long enough power lead to use. It also comes along with its bracket, and it comes with some black masking tape, which is probably holding the front onto the lids. And the whole thing looks like it could well do with going through the company dishwasher. Not sure why that's there. Now these are a 24 volt set, if I remember rightly. Well, some versions of this are a 24 volt set. It should be 80 channel as in CPT, EU, FM only. I'll put the soldering iron on because I'm sure we have to unsolder the speaker. So I don't know the origin of this. Yep, we have to unsolder the speaker. I think we'll take the bottom off this because I really think it'll benefit from going through the dishwasher. Someone says, well, I look at their valve radio. I said, yeah, but we'll put the chassis through the dishwasher. That should put them off. Yeah, that's what we do with valve kit. We take the speaker off, we take the, if there's a meter, we'd take a meter off, but the whole chassis will go through the dishwasher. I don't pussyfoot around here. Right. So we'll get it connected up. I'm not sure where the payment. Oh, they're here. I was going to say I can't spot the crocodile clip lead. So waiting. We're doing that radiogram and put it back together, and then doing a video and all that. And blow me, the stylus was no good, so I've had to order a stylus. So that's still going to get finished. My homebrew 7-meter set. I was going to make a new tank coil for it, but when I looked at the screws I'd got, they weren't the right ones. So I thought, well, instead of making a pig's ear of it, we'll wait for the right screws. So there's lots of things going on, but not necessarily on video. So we can see that that's why they've put the tape on that, because it's grinning at that side. I think we might just glue gun that side rather than put the tape on it. Right, so we'll connect it up to the test equipment. Two of our customers over the last from the last year have taken their first amateur radio exams and passed. And they're both customers who have done end user repairs for, which we don't normally do. How do you switch this on? Ah, you hope it doesn't have a bent shaft. That's going to be interesting. But pause the video. Okay, so I've got the on volume off, and it's simply a matter of unsoldering the printed circuit board there and the connection to the squelch control, then taking out the nut and removing it. But they're not standard parts. I can't pick up the RS catalogue and get one of those. So we've got to look on a scrap chassis, and it's the kind of thing which we're going to find, I'm sure. Let's see how many ohms it is for a start. $20K. Well, it's going to be an interesting one. So we're looking for some kind of scrap baby Midland. Right, well, I'll go to our storage shed and see what I can find. Well, I think we've got somewhere. Look, I found a Kerner Beta 1100 here in the scrap bin with a broken front panel, and has already been rolled. I'll have bought it from a radio rally like this. And when I come to look at it, it has this same printed circuit board arrangement, so it looks like it's got the same control, and it's got certain similarities, though this has got more crystal filtering on the receiver. This is not the 24 volt version. I found a scrap one of those, and the volume control had already been liberated. So I'll unsolder this one. At the end of the day, you know, these are now 20 years old as well. That should now remove. And the nut's already missing, which makes it easier to take out. Oh, good. Nut hasn't got a bent shaft. So it's a different colour. Let's see whether it's the same number of ohms. So the original one is 20K, so if I put my prods across the inner and outer of the potentiometer track, we should have more or less 20K, which we have. Let's see what this one reads. Fingers crossed. Yes, 20K. It's a bit nearer 20K. Well, that's brilliant. I'll just put some Servicol in there and just clean it, because goodness knows how long that's been in there, but at least 5 years. Good. Trouble is, we've not bought any scrap chassis since lockdown began a year ago. You know, we go to radio rallies, and well, I send Mark, and I'm usually busy at church, but I send Mark and Mr. Chippy to radio rallies, and they usually come with something. You know, we tend to buy scrap chassis for a couple of quid each, and it all helps this kind of thing. But because we're stuck otherwise. Right, well, that should be tight enough. Let's see whether we can get the printed circuit board back on. That track's lifted. I've just got that one pin that lifted. Right, let's put the power supply on, see what happens. What's an improvement? So clearly you don't have to plug a mic into these for it to make a noise. So which band are we on? No idea how you tell. So what we're going to do is put the signal generator onto channel 20. Ah, there we go. I had one of these in the car. I had a pickup truck and it was mounted behind. So I had to reach to the rear cab bulkhead. And I had no idea which band it was on. So that's obviously CPT. And that's not, but solely because I'm getting the signal generator. How naff's that? Do that from the mic as well. Anyway, it's receiving beautifully. And before we start, we can jot down so it's Midland 38. Put that on the cyanide meter. Put picture in picture in. For 12 decibels we'll now go over to the attenuator. The big hand's on 0.3, the small one is on 0.3. So we've got RX 0.3 microvolts for 12 dB cyanide, and that is excellent. Let's look at transmit. We're doing this topsy-turvy today. Turn the volume down. So over to transmit, we'll put the other meter on. That's one of those, is it? Unplug the extension speaker. He's doing 3 watts. And the deviation, wallow, it's 1.8. Is it on frequency? Let's have a look. Not far out, 27,79108. So we'll just bring that up to 27,79125. That we've either got a duff lead something's not 100%. Oh, I overshot it now. I mean, it didn't need adjusting anyway. It doesn't need adjusting now, but I just like to be meticulous. That'll do. I can't remember what. You haven't got a meter on these sets, so that's one thing we don't have to faff with. I can't remember what the presets are. So we'll have a look at the circuit diagram. I printed off this. This came with in the back of the instruction book. So we've got 4 presets. Well, we haven't. We've got 5. So I'll have a look at this. Well, chances are we're going to have a squelch. Volume, squelch is normally preset. Got VR3, VR2, and VR1 is going to be the squelch. VR2 is going to be transmit meter. VR1 squelch, VR2, VR3, VR4, VR5. It's going to be TX meter. That's going to be RX meter. That gives us 4 and 5. So deviation's going to be somewhere around here. VR4 looks to be deviation. It finds its way from the varicap diode to the preamp output from the TDA2002. So it looks like that's used as the microphone preamplifier. And then I think we've probably got power adjustment, to be honest. So let's just look around there. Yeah, VR5 is going to be power regulation. Okay. So VR5 is oh, this is nice. They've done this nicely back to front to make it easy, yeah. So 5 is that one. So from there we'll go back to the power meter. Press transmit. If we can persuade it to do so. It's breaking this wire somewhere. So it's now on full power, which is doing 3.2 watts. Then we'll run through these coils. Maximum. 3.5 watts. Yeah, it's doing 3.6, and that's where it is. We're at 13.8 volts. Yeah, 3.6. So at what point does it become 4? When I turn the power supply up carefully. At 14.5 volts, it's 4.2 watts. It becomes 4 watts at 14.1 volts. And what does it become at 12 volts when you're running off a caravan battery and the battery's going flat? It does 2.5 watts at 12 volts. Okay, so back to 13.8. Deviation. VR4. This is mirror image just to make things more fun. One, 2, 3. Must be there. Let's get the little oscillator out and see what we can see. I'm going to have to sort this mic out. It's a pain. I can't tell what end it's duff at. Wallow. There we go. Drop that off a fraction. Wallow. There. And another fraction. Wallow. There we go. So we've got no meter. Oh, we have. Of course we have. I was talking about the meter, wasn't I? So VR 2 is the meter. And that is 2. Well, that's I've misunderstood that one wrong. Don't say it's 1. No, it can't be. It's got to be 2. I'll tell you what, we'll drop the volts down so that it does less power on transmit. I'll drop it down to 12 volts and then try and adjust it. Wish this thing wouldn't change channel. Oh, it can't be that one. Nah, no idea why that is. And we'll come back to that. So we'll look at receive. And we'll plug it back into the test equipment. Alright, we'll go through the receiver. Start with the detector. And put S9 equivalent on. Turn the bench light off so people can see it a bit easier. And the detector coil looks to be that one. It is. There we go. So now we'll go over to the cyanide meter. That was virtually spot on. I mean, I touched it, but there you go. I don't think we're going to get any improvement on this because it's already excellent. I don't know, we just gained a bit there. I'll just put a bigger signal on for the IF. No, we're not going to get any improvement on that. So I'll go back to an S9 signal. And this time, when we adjust S1, VR1, we should have the S meter. No. Oh no, that was squelch, wasn't it? VR3 is RX meter. Okay, so that's that's what you call a lazy meter. Don't tell me that it's affected by that. So now if we're going to transmit, it still reads 4. It does annoy me when sets play this feedback game. I just can't get the RF meter to read any lower, to be honest. Tell you what, we'll back off the transmit power. I'm going to unplug that extension speaker. It wastes such a lot of time, things like that. So I've turned it down now to 1.5 watts. So let's see whether we can get that meter to come down. No. No, I can't work out what's happening with that. And we're on the wrong band again. No. Go back to the speaker. Put the power back where it was. So we'll look at the squelch. So I'll put the squelch to full on the radio. And now we'll take off the signal generator. VR3. No, VR1 is squelch. VR1 is definitely squelch. Okay, so that's brought back squelch action. So we'll put the signal generator back onto full. I'll put the camera on there. So switch that back on. We'll turn squelch to full. Let's see where that comes in. See whether we can have it a bit coarser than that. VR1. That's coarser. I want it to come in at that. That's 100 microvolts there. So that's just in. That's perfect. Coming in at 100 microvolts, not coming in at 30 microvolts. So now we'll drop the squelch and turn the signal generator off, parking it at 0.3 microvolt. Squelch to threshold, signal generator back on. It's coming in. Turn that volume down. So it's coming in at, turn that attenuator a bit. It's coming in at 0.4 microvolts and it's leaving about 0.2 microvolts. So let's look at what the overall synad now is. Because I think there was a little tiny bit of improvement, even though it was excellent the way it came. So go back to that camera. Turn the squelch down. So there's 12 decibels. We're at 0.26 now. And I'll show you that on here. So the little hand's on 0.3, 0.3, 0.25. Good. So I need to look into this microphone, and I think we've got a problem at this end and a problem at the mic end. Okay, so I've got to the bottom of the intermittent transmit. There were several reasons. The microphone needed cleaning in on the contacts. That's the audio side of it. Just check that. I'll just switch it on. Wallow. 1 2 1 2. I'm probably on the wrong band. Wallow. Now it's too loud. It was hard to judge, wasn't it? So we'll just get the oscillator back and sort that out. Oh dear, that's one of the knobs on the floor. That's never to be seen again. And I've got this the other way. No, I haven't. I've got it there. We'll just use that screwdriver. Here we go. Right about there. Wallow. No, it's even louder. It's an electric mic, and it's seems to be hard to pick up on the oscillator. Let's try it there. Wallow. 1 2 1 2. Wallow. Yes, I think we can just get that to go. Make sure the power's back up. Yep. Right, we'll connect the speaker up. So the lids have been through the dishwasher, the knobs have been through the dishwasher, apart from the knob I lost on the floor, which has been through the dishwasher and now gone on the floor. Mr. Chippy's raring to go. So to be honest, I mean, this is another scrap set. Let's get that bit of solder out of that speaker. So you know what will happen otherwise, it'll go in the works, won't it? Well, at least the speaker works. I mean, how many sets do we get in where that doesn't happen? Might have to finish putting the lids on later. Mr. Chippy can get in the car if he likes, but I'll have to get the camcorder out. You've stood in the doorway, as good as gold then. So we'll put that volume control in the bin. In the bin, did I say that right? We'll pop it on the aerial. But which band am I on? 3 pips when you switch on. What does that mean? I suppose we've got to go to... You know, it's very, very annoying. I have to get a monitor receiver out. Oh, that's 19 then. Actually, we should have said 19 Roger. 19 Roger. That never works, does it? Okay, well, we'll go up there and we'll get the camcorder on and we will do an on-the-air test. Just checking you can copy.
Yeah, roger that.
Right, just get the camcorder on.